All right, so we're gonna look at linear systems, specifically get started into this idea of working with them graphically, meaning let's find the intersection of graphs. This should be somewhat of a review idea from a grade 9 concept, and then we'll move on to substitution elimination methods, which are purely algebraically finding the intersection of these graphs. So here we have a situation where Janice is starting a business selling dog treats. She's figuring that she's gonna cost her about $20 per week in operation costs, plus another 50 cents for every treat she makes. She then plans to sell those treats for $1.50. And we want to figure out how many treats does she need to sell to make even money. Even money means that she's gonna break even. She's gonna make as much as she spends. So it's a break even point. So to do that, we need to kind of figure out what are the mathematical equations that we have here. What's her cost equation? Well, her cost equation is going to cost her $20 per week plus 50 cents per treat. So the money she's spending is $20 per week plus 50 cents per treat. So each week, she's spending $20 and an additional 50 cents per treat. Her profit, she's selling each treat for $1.50. So the money she makes is going to be 1.50, $1.50 times the number of treats. So this is her cost, this is her profit. The point where they intersect is where she breaks even. When this profit is higher than cost, she's making money. Now, these two equations, as they stand, where we're interacting with the same question here, these make up what's called a linear system. So a linear system is a set of linear equations, two or more, that create the solution to a realistic situation. Or situation in general, it doesn't necessarily have to be realistic. Let's see if I can cut that. I'm going to try and just do this way. So these two equations here, what they make is a system of equations. And so a system of equations is a set, a group, more than one, so 2, 3, 4, or as many as you have, of equations that relate to a problem and are interconnected in that they will have the same set of variables, and if graphed, will possibly intersect if the given situation calls for it. Two or more equations. This is my abbreviation for equations, by the way. EQ with a subscript N. So again, they're connected on the same plane, meaning they have the same variables, x, y, in our case, m and t. So this is a system of equations. We can then plot these on the graph, and this is hand-drawn graph, so it's not perfect, but I can use the slope y-intercept method here. There's my y-intercept of my cost here at 20, and then it's 0.5t. So for every $10, it's going to go up 5. So at $10 it'll be about 25, at $20 it'll be at 30, At $30 should be about 35, and at $40 it should be up another 20, so at 40. So this is my cost line here, and then just to use a different color here, I'll use my profit line. So my profits are $1.50 T. So for every treat, I'm making $1.50. So for every 10 treats, I'm making $50. So 0 treats, $0. 10 treats, $15. 20 treats, $30. 30 treats is going to be up here at 45 somewhere, so approximately here. But I have enough dots here with my 3 to connect the dots. And I now have my 2 lines graphed together, and I have my point of intersection. So this point here is called the point. The point of intersection. I'll often use the abbreviation of POI. And what that is where the equations meet. And again, this could be 1, 2, 3 or more equations. It doesn't have to be a line. In grade 11 math, you'll actually take a look at this using some curves as well as the straight lines and such. So key points here. When we have a set of equations that have the same set of variables, so they're graphed on the same set of axes. Here I'm in t-axis, so this would be our t-axis. This would be our m-axis. When they're graphed on the same set of axes, they make up a system of equations. Could be 2, could be 3, could be more. And then where those equations intersect is called the point of intersection. And we can often use this short abbreviation of POI just to simplify things.